Okay, now question 4, we're wanting the minimum value of the expression. The problem here is that we've got a cosine wave and we've got a sine wave, so we're going to try and combine this together and make one wave. So first thing to realise is that if we take the cos x minus the 3 sine x, I'm not sure why I put a bracket there, so let's just take that away. Take away the 4. I think what I was wanting to put a bracket is that we're going to put brackets around here, and we need to rewrite this so it's got one identity. Okay, so it ends up using, so if we look at the r cos theta plus x, because if you look at which one matches up better, then we're probably going to be able to match it up to the one that ends up with r cos alpha cos x minus r sine alpha sine x. And where I'm making that decision from is this minus sign and the minus sign here, which then will make it work out a little bit better. So we've got to equate the coefficients of this bit in here. So we end up, if we've got the cos x and the cos x, it means that r cos theta is equal to 4. And we've got r sine theta is equal to 3, which means that we can square and take the square root, which means that our r value equals 5. Once we get our r value, we can either sub that into the equation to work out our theta, or we can use sine over cos, so which gives you tan theta equals 3 over 4, which gives us our answer of 36.87. Now, what we then have to do is we've rewritten this part, okay, the bit in the bracket, using the r cos theta. So this ended up being replaced with r cos theta plus x. Okay, that was what this bit here is equal to. So what we now need to do is rewrite this. So our r is 5, so we end up with 5 cos theta is 36.87 plus our x. Sorry, I've written that the wrong way around. It shouldn't matter since it's both adding. So, and then we've got the takeaway 4. What we then have to do is we need to think about the graph. So we've got a cosine wave. So this is going to be probably a pretty bad drawing. Okay, we've got a cosine wave which normally goes to 360 degrees and starts high. And normally it goes between 1 and minus 1, but we're timesing it by 5, so we can straight away say, well, that's going to be 5 and minus 5. But then what this does is shifts the graph down. So we're going to end up taking that one out, taking 4 off it, which makes 1. Take 4 off that, which gets us minus 9. This tells us that the minimum point is going to be at minus 9. Now, this is normally at 180, but we're now shifting it back 36.87 because remember our graph's transformation, which means that this is going back 36.87, which gives us an answer of 143, which means 143.13, and the minimum value is minus 9, which is what it then asks for.